We now begin the first of two units where we talk about chemical reactions. So I think the best place to begin is to ask the question, what is a chemical reaction? So my definition is that a chemical reaction is the process by which one set of chemical substances is changed into a different set of chemical substances. So there are several terms that you need to be aware of surrounding the topic of chemical reactions. So three terms, reactant, reagent, and starting material, are all terms for the substances that are undergoing the change. And these terms are used pretty interchangeably by chemists. And then products refers to the new substances produced after the chemical reaction occurs. In many cases, there will be multiple products and we only care about one of the products, so we sometimes singularize it and say the product. But in most, not all reactions, more than one product is actually produced. Okay, so here's an example of a chemical reaction, or at least of the starting materials and product of a chemical reaction. So sodium metal, which is the kind of gray cylinder on the top left-hand side of the picture, plus chlorine gas. Okay, so chlorine is a yellow-green gas. We have it captured in this volumetric flask so that it can't get out. If you were to react these two elements together, the product is going to be sodium chloride, which is actually table salt. And what I want you to note as evidence that a chemical reaction took place is that the product is very different both in appearance and in chemical properties than either of the starting materials. So that is consistent with the fact that two chemical substances have been changed into a different chemical substance. Okay, so what we need to do in the rest of this lesson is come up with a method that we agree on to describe chemical reactions. How do chemists talk to each other about reactions? So a reaction itself is an event that takes place in the lab between two or more chemicals. What we need is a way to describe what is going on in that reaction, either on a screen or on a piece of paper. Okay, so in moving towards this, here is a picture of a chemical reaction actually taking place. What would your caption for this picture be? Yeah, I know, fire, right? Yeah, there's fire there. But how can we describe using words or symbols in a scientifically precise manner what is going on? Well, one option would be to use complete sentences. So the complete sentence for what is in this picture would be, when we drop a small lump of sodium metal, same sodium metal except we've got a different second reactant, into a container of water, hydrogen gas forms rapidly and sodium hydroxide is produced in solution. That's fine. It's a bit wordy. It would be very wordy to write it, and it's even wordy to say it. Okay, so we can come up with a shorthand. How about an equation using chemical names? So just taking the chemicals out of that sentence, sodium plus water gives sodium hydroxide plus hydrogen. Okay, well that's fine. Another option could actually be a cartoon drawing. So we can kind of draw the atoms, the ions, and the molecules that are participating in this reaction, showing the reactants and showing the products. All of these are useful in certain circumstances, but the most common way we describe a chemical reaction on paper or on a screen is to use a chemical equation. So the chemical equation makes use of the chemical formulas that I already introduced to you in a previous lesson. So the chemical formulas for this particular process is Na plus H2O gives NaOH plus H2. Okay, so notice that the reactants are placed on the left side of the equation. You put a plus sign between the two reactants, then you have an arrow, and the products are placed on the right side of the arrow. And if there's more than one product, you also have a plus sign between the two products. Okay, so that is a chemical equation that contains all of the information that the words and on the previous slide contained. But with chemical equations, we actually frequently want to convey a little bit more information about the reaction that's taking place. So for most chemical equations that we will write in this course, we will also include the state of matter for each reactant. And the reason why I like this particular reaction as an example is it involves all 4 states of matter that we're going to be writing in chemical equations. So the sodium reactant is a solid, the water reactant is a liquid, and then the hydrogen, the H2 product, is a gas. The other product is sodium hydroxide dissolved in water. Remember, there's still water left. We haven't used it all. And the way we write that is we put an AQ in parentheses after the NaOH to indicate that this is an aqueous solution of sodium hydroxide, or rather a solution in water. Okay, so one more point I want to introduce in this lesson. For many of the problems we will need to solve in this course, the equation will also have to be balanced, meaning that the reactant side and the product side must have the same number of each type of atom. So the equation that's written here is actually not balanced because there are only 2 hydrogen atoms on the left side as part of that water molecule, but there are 3 hydrogen atoms on the right side, 2 of them in the hydrogen gas, and then 1 of them in the NaOH. Okay, so you're going to learn to balance equations very, very shortly, but as a preview, here is the properly balanced equation, including the states. So 2 sodiums plus 2 waters react to give 2 sodium hydroxides and 1 H2.